Now, in this case, see, now we are discussing that even though the temperature, even though we are not boiling, we are seeing that water is getting converted to water vapor. So this occurs because of that is particles at the surface of the liquid. They will absorb energy from the atmosphere, and they will get their kinetic energy will increase. So the kinetic energy increases, that energy is enough to break the force of attraction between the particles, and it can escape into the atmosphere. So when it is escaping into the atmosphere, we are seeing it as water vapor. So water has actually broken from the other liquid molecules uh, and escaped into atmosphere, and we call it as water vapor, isn't it?
Ma'am.
So that is why below the boiling point also the water can get converted into water vapor. But depending on that, there are different factors. As we said, there is effect of temperature, then there is effect of that is wind velocity. We will read that now. There are other factors that will increase or decrease the rate of evaporation. Okay, now who read that now? Who's the next person? Let me just see. Prerana finished. Now Priyadarshini. Before Priyadarshini reads, I have a doubt here. That is does all gas get converted to solid when the pressure is exerted on them? No, not all gases get converted into solids or liquids. See, some gas, when you apply a lot of pressure, they get converted. They're under a high state of pressure. They have not got converted to liquid, nor have they got converted to solid, but they are under state of pressure. This we have discussed. What is the example? When you're
Dry ice.
See, dry ice, so carbon dioxide is getting converted into solid. So gas is getting converted into solid. Okay, so that is an example. So the question is, does all the gas get converted to solid when pressure is exerted on them? So what do you think is the answer? Anyone? Okay, I'll ask Aishwarya. What do you say? The question is, does all the gases get converted to solid when pressure is applied on them? So what will first I'll ask everyone. Let us see what Aishwarya says.
No, ma'am.
No, I'm having a question now. My question is, will all gas get converted to solid when I'm applying pressure on them? What is your answer?
No, ma'am. All gases will not convert it to liquid when we apply the pressure.
Yeah, they will not get converted to liquid, nor they will get converted to solid. Depending on the characteristics, you have studied now molecules, atoms, depending on the characteristics of that particular whatever is that matter, it gets converted to liquid, some will get converted to gas. Now, some will not get converted to either solid or liquid, but they will remain in a high state of compression. And we have discussed that. What is that? Anyone?
Ma'am, CNG.
Very good. So compressed natural gas is an example where gas is in a state of high pressure, but it is neither a liquid nor a solid. Compressed natural gas. Very good. In case of liquefied petroleum gas, the gas has got converted to liquid. In case of dry ice, carbon dioxide has got converted to solid. Isn't it? And even this camphor, see, we studied last class, we discussed that experiment. So either it is camphor or ammonium chloride. When you heat, it will evaporate. But at the mouth of the funnel, we discussed, in the mouth of the funnel, this gas will go, this vapors will go and again condense. It will get condensed to, again, solid ammonium chloride near the neck of the funnel. Did we not discuss last class?
Ma'am, we discussed.
We discuss. So there gas is getting condensed to us. There it is, vapor is getting condensed back into the solid state. Okay. So we had sublimation and then we had condensation. Okay. So this is clear now, Sahana?
Yes, ma'am.
Very good. Okay. So now we will continue. We have 1.4 we started. Now who will continue after Priyadarshini, I think. Isn't it? Priyadarshini,
Yes,
read the
ma'am.
next aspect, next part.
Factors affecting evaporation.
Hmm.
Activity 1.14. Take
Hmm.
5 ml of water in a test tube and
Hmm.
keep it near window or under a fan. Take
Hmm.
5 ml of water in a open china dish and
Hmm.
keep it near a window or under a fan.
Hmm.
Take 5 ml of water in an open dish. Keep it inside a cupboard or a shelf in your class. Record the room temperature. Record the time or date taken for evaporation process. In the above cases, repeat the above 3 steps of activity on rainy day and record your observations. Pursue info about the effect of temperature, surface area, wind, velocity, speed on evaporation.
Okay, very good. So what did you understand, Priyadarshini, from this experiment?
Ma'am, we should take 3 different bowls and we should pour water in it, and one should be kept under fan,
Hmm.
one should be kept in the uh, window, near window, and
Hmm.
one should be kept in cupboard. And we
Hmm.
have to observe the room temperature.
Hmm.
What will be the room temperature after the time or the certain day that we should take.
Okay. So okay. Now here, okay, very good, Priyadarshini. Next, Sachin. Sachin, what do we observe here? Where will evaporation be faster? Suppose I'm keeping in 3 plates, that is one under the fan, near the window, then inside the cupboard. Where will evaporation be fast? Where will water evaporate? Have you,
Ma'am, under the fan.
under the fan?
Under the
I mean,
family.
okay, under the fan. Okay, it also depends on the temperature. Suppose it's very hot, maybe near the window also, but maximum under the fan. So evaporation is depending on that is fan. What is increasing when your fan is on? What is increasing?
Wind speed is increasing.
Well, yeah, we can say air velocity is increasing. That is one. So if I'm keeping, Sachin, if I'm keeping in a glass, so I'm keeping in a glass or I'm keeping in a plate, where will evaporation be fast?
Plate, ma'am.
Plate. Why? What is happening? What is the difference?
There is an increase
Plate
in surface area.
Yeah, plate has more surface area when compared to the glass. So whatever water that is there in the only surface will get the energy and will be able to vaporize. Plate means larger surface area, so as a result it can evaporate faster. So all the molecules of water, all the particles of water can get the energy from the atmosphere and then they can vaporize. Now okay, suppose it's a rainy day. Rainy day versus an ordinary day. This Sachin, just try this answer. Rainy day versus ordinary day. Which day will this water evaporate fast?
Ordinary
An
day.
ordinary day, ma'am.
Ordinary
Ordinary
day,
day.
ma'am.
Okay, okay. Why in the rainy day it will not? It cannot evaporate fast.
Ma'am,
Because it,
on other days,
Okay,
evaporation takes a longer time on rainy days, ma'am.
okay. It takes longer time. Okay, that's a yes. That is right. Now my question is, okay, I'll ask Sachin only because Sachin, you should try to answer. Why on a rainy day evaporation is less?
temperature is less, ma'am.
No, let us say sometimes it will be say 28 degrees. It will be 28 degrees, but it will be some months during the monsoon. It will be 28 degrees only, but there will be a lot of water vapor in the air. So more than in that condition, if temperature is the same, it will be what is during that the rainy day, what will happen usually? What is more? Water vapor already in the air is,
Atmosphere.
yeah, air already has some water vapor because of the rainy day. There is moisture, so water vapor is present in the air. So so as a result of which, there is a particular amount of water vapor that air can hold. Okay, and if it reaches that particular level, then no more evaporation can take place. Okay, so my question is, what is that? What do we call the amount of water vapor present in air? What do we call?
Humidity.
Excellent, excellent. Humidity. So at a particular temperature, water has a particular humidity, and if it is already what we call saturated, then no more water, water can evaporate, or it will be very slow. So that is why in a rainy day, if you are drying your clothes, it will not dry. No, you have observed anyone?
Ma'am.
You
Yes,
have
ma'am.
observed. Observed. And also last class we discussed, suppose you take a towel and you spread, it will dry fast. Suppose you take a towel, you just wring it and just put it like that, then you can see wherever it is not exposed to atmosphere, it would not have dried. Okay, so thus we can say surface area is one factor, humidity is one factor, then temperature is another factor. So anything else affecting
Wind, ma'am.
evaporation?
Wind, ma'am.
Very good. So wind
Wind.
velocity. So you can see that is a dry day, when in a windy day, the clothes will dry very fast. So these are the four factors that affect evaporation. Very good. So now, Priyadarshini, Sachin has to read. Sachin, okay.
You must have observed that the rate of evaporation increase with an increase of surface area. We know that the evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increase. For example, while putting the cloths of dry up to spread them out. An increase of temperature. With the increase of temperature, more number of particles have kinetic energy to get into a vapor state. A decrease of humidity. Humidity is the amount of water vapor present in the air. The air around us cannot hold more than definite amount of water vapor at the given temperature. If the amount of water in air is already high, the rate of evaporation decrease and increase in a wind speed. It is a common observation that cloths dry faster on windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decrease the amount of water vapor in the surrounding.
Very good. Okay, good. Next, Samiksha. So we have discussed this aspect. Next, Samiksha, continue reading.
Okay, ma'am. How does evaporation causes cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorbs energy from the surroundings to regain the energy lost during evaporation. This observation of energy from the surrounding makes the surrounding cool. What happens when you pour some acetone nail polish remover on your palm? The particles gain energy from your palm or surroundings and evaporate, causes the palm to feel cool. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Can you
Very good.
cite some
Huh. Yeah, continue. Okay.
Can you cite some more examples from daily life where you can feel the effect of cooling due to evaporation?
Very good. So the point is, evaporation causes cooling. Okay. So why does Samiksha evaporation cause cooling?
Ma'am, due to the liquid absorbs energy from the surrounding, the energy which has lost during the vaporization, so to absorb the energy during from the surrounding, it causes cooling, ma'am.
Very good. So actually, to evaporate, it needs energy. We studied no latent heat of vaporization. It needs energy to go to the gaseous state. So it will take the energy from the surroundings. So as a result, the surroundings will become, it'll become, there is a decrease in temperature. So it becomes colder, it becomes cooler because energy has been lost during evaporation. Okay, very good. So what is the example they have given, Samiksha? The first example is?
Nail polish remover, ma'am.
So why does it become cold when you are applying that nail polish? Anyone has done this? Anyone has seen this? Samiksha, did you ever try?
Yes, ma'am.
So what happens when you apply onto your hand? That nail polish, it will evaporate, no?
Yes,
It will
ma'am.
cause cooling. It will evaporate very fast,
Yes,
isn't
ma'am.
it? You will get the smell. So it is actually basically like a solvent called acetone. So acetone, no, it is having very low boiling point. So low boiling point means some energy is enough for it to get converted to gas. So you observe cooling. Okay, very good. So next question, I have a question. See, in like in some places, the house will have a mud roof in very hot places, and then they will pour cold water onto that. So when they keep on in summer, they'll be pouring cold water onto the roof to reduce the temperature. How does this take place?
Ma'am, due to latent heat of evaporation of water helps the cool the hot surface.
Yeah, so the water will evaporate from the surface. When it evaporates, it will take energy. So as a result, it will cool that particular area, and then slowly heat will be like lost. As more and more water evaporates, it becomes colder and colder. Very good. So next person, who is it after Sanjana? Okay, Sanjana, continue.
Yes, ma'am.
Mm.
How does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surrounding.
Ma'am, complete now.
Yes, okay. Sanjana, please continue.
Ma'am, is it completed?
Have you completed that particular aspect?
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am, complete.
No, there is okay. 1 second.
Why should we wear cotton clothes in summer?
Hmm.
During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles that the surface of the liquid gain energy from the surroundings or body surface and change into vapor. The heat energy equal to the latent heat of vaporization is observed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation.
Very good. So, what did you understand, Sanjana? Why do we wear cotton clothes in summer?
Cotton is a good absorber of water, ma'am.
Hmm.
In summer, we are sweating. No, it will absorb the sweat from our body and it causes cooling. So we wear cotton clothes in summer days.
Very good. So, it will absorb the sweat and then it will expose it to the atmosphere. So, atmosphere, there will be evaporation. So, more and more sweat will be evaporated and we feel cool. Very good. Excellent. So, next, Shravan Kumar, next aspect, next part.
Why do we see water droplets on the outer surface of a glass containing ice cold water? Let us take some ice cold water in a tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in the air on coming in contact with the cold glass of a water loses energy and gets converted into liquid state, which we see as water droplets.
Excellent. So what we have to do here in this experiment, what is the experiment here? What is the, I mean, what did you understand from what you read?
We take a one tumbler and we put the ice cold water. In this experiment, we see that the water droplets will come out outer surface. We see that the water droplets are outer surface of the tumbler. And when the water droplets are outer surface of the tumbler, it loses its energy and gets converted into liquid state. That's why we see that the water droplets can see in the outer surface of the tumbler.
Very good. So what is happening? See, I have got some ice water. Just I don't know whether you can see that water vapor. I mean, it's clear. So I have in a tumbler and I'm adding ice water. So if can you see slow? See if you can see. You can see the difference. All of. Can you see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So we can see more and more, this actually this process is called condensation. So the air that is around this, when the air comes in contact with this cold surface, it loses energy. So air has water vapor. Water vapor will get converted to the liquid state. No, it is clear, no? See on top where I'm holding, no, there is no condensation. Because here the temperature is not cold. So here the air, there is no change in the water, that is water vapor present in the air. Here, only here, because inside there is ice water, so the water vapor in the air has got converted to liquid, from vapor state to liquid state because of decrease in temperature. So clear, students?
Yes, ma'am.
Yes, ma'am. Why the water vapor loses its energy?
See for example here it is the temperature now I think is 25 degrees centigrade. So 25 degrees centigrade can hold some amount of water vapor. Okay, so this air when it comes here there is ice. So there is ice and water. So the temperature here must be 5 degrees centigrade. Okay, at 5 degrees centigrade, air can hold only some amount of water. So the excess amount of water, what will happen is it will sort of precipitate out, one point. Second point is here when it is coming in contact with a lower temperature. So this water vapor, the kinetic energy reduces. It is losing its heat. The kinetic energy reduces. So again, this water molecules, the particles, they will go back to the liquid state. So we studied, in evaporation, heat is required. Latent heat of evaporation is required to convert the liquid to the vapor phase. So that when you are lowering the temperature, here the temperature is less. So much of energy is lost. So that all the water molecules, the kinetic energy will reduce. Then the force of attraction will take over. So when the force of attraction will take over, it will become a liquid. Again, if that is what is happening in the fridge also. So you're taking water, you're reducing the temperature, then there it is becoming a solid.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any other doubt?
No, ma'am.
So this is so here we are seeing this process of air that is present in the that is a water vapor present in the air. It is now condensed. It has become liquid. So from the gas phase, it has got converted to the liquid state. Okay, very good. So next, is there anything else in the after that?
Some
Come on,
questions.
some
Okay. We'll take up a okay. So we will start with the question answers. So who completed now? I think who's is the next? I think Shravan Kumar. Shravan Kumar completed. No, now.
Yes, ma'am.
Okay, Shweta. So we'll take up the first
Yes,
question.
ma'am.
Read the first question.
Why does a desert cooler cool better on a hot, dry day?
Okay. What is your answer?
A desert cooler increases the humidity of the surrounding air. The water particles in the air take the heat from the surrounding objects and evaporate.
Okay. Again, can you please repeat?
Desert cooler increases the humidity of the surrounding.
Uh,
The water particles in the air take the heat from the surrounding object and evaporate.
okay. Right. So what is our question?
why does a
Why
desert
does
cooler cool better on a
on a
hot, dry
hot,
day?
dry day? See, there's a hot day, hot, dry day is there. So why does it cool better in a hot, dry day? See, dry. Okay, let us have a hint. Dry day, no? What will be the humidity in a dry day? What will be the amount of water vapor in a dry day? Shweta?
Oh,
Yes, ma'am.
What will be the amount of water vapor in the air on a dry day? It will be more or less dry day.
ma'am,
If
less.
it's a dry day, it will be
Less,
less.
ma'am.
So since the humidity is less, so as a result of which the evaporation rate of evaporation will increase when compared to say a wet day, isn't it? Yes or no, students?
Yes, ma'am. Yes,
Okay.
ma'am.
Okay, very good. Now, someone else will also tell me the answer. Who else will tell me the answer for the question?
Ma'am, can I?
Who is it? Name?
Madhumita,
can I?
ma'am.
Madhumita.
Can
Okay,
I?
Madhumita. Yeah, Madhumita will answer. Everyone will get a chance. Yeah, Madhumita.
Ma'am, it is because the temperature is high and less humid on hot dry day, which enables better evaporation. High level of this evaporation provide better cooling.
Correct, exactly. Perfect. So first we have two aspects. One is it's a dry day, it's a hot dry day. So what happens is the rate of evaporation will be faster. Two factors. Okay, so as a result, it works better. Very good. So next question. Okay, before. Okay, next question. After that, we'll take
How
a
does
doubt.
the water kept in an earthen pot become cool during summer?
Sorry.
According to Topper, water kept even in summer because of evaporation.
Sorry, I can't hear. It is not clear. Okay, Sneha. Who answered? I mean, who spoke? Just now somebody spoke. I didn't understand that. It was not clear to me. Who was it who spoke? Okay. Now we'll take up. Sneha, please continue the next question.
Yes, ma'am. How does the water kept in an earthen pot become a cool during summer, ma'am?
Okay. What is your answer?
In an earthen pot has a large number of tiny pores on its body, ma'am, and a small amount of water seeps out from these pores and get evaporated from the surface. The heat required by for the evaporation comes from water inside the pot. The water inside the earthen pot keeps losing heat. Then the remains cool, ma'am.
Very good. Okay, very good. Any other answer, students? Anything you want to add to this? No? So as Sneha said, this earthen pot has tiny pores. So water will say it will go through the pores. It will pass through these pores and then it will evaporate. So for evaporation, energy is required. So it takes the energy from the surroundings. So more and more water evaporates, more and more energy is taken, as a result of which the water inside is cooled. Yes, Shravan Kumar, you have anything to say?
No, ma'am.
Okay. See, another way we can also do, if you are some places know there, you can see what they will do is earthen pot. On that they'll put some wet cloth also. Has anyone seen that?
Yes, ma'am.
Yes,
So
ma'am.
that again, so that you again more and more we can cooling can be faster, and you can have further reduction in temperature inside the earthen pot. Okay. Okay, very good. So next question. Uh, who is it now? Spurti. Yeah? Before that, sorry, Prerna had a doubt. With a mixture of naphthalene and ammonium chloride, suggest a activity to separate them. Good doubt, Prerna. Anyone can give an answer? Anyone wants to answer this particular doubt?
Ma'am, by sublimation process.
By sublimation process. Okay, both of them are subliming, no? How will we separate?
Ma'am, both of them are sublime. They both will get evaporated.
So how do we separate them? Can we separate them? How we can separate them? Any way we can separate them? Okay, we can. Okay, we can think of one hint. I can give melting point. By considering the melting point, can we separate them? Yes or no? Okay, another doubt, another hint. Suppose there is a difference in their melting points. Can we separate them?
Yes, ma'am.
Okay. How? No, good. That's a point. This one. Just how you think we can separate them, knowing the melting point.
And one has less melting point, so that get evaporate, and one has more melting point that converts into liquid.
That will take longer time. See, actually, if you keep both of them, and you suppose there is a difference, we should check the melting point. What we can do when you are heating, the one that is having a low melting point, because it is sublimation, it will go fast and it will go and deposit at the top. Let us say, if you are using a inverted funnel, the one that is having less melting point will take longer time, and it will not be able to travel that much distance, so it will go and get deposited maybe at the near the mouth of the funnel. So if the melting point, there's a lot of difference, we can see fraction. See, one region it will be most probably naphthalene, and down you will have a layer of ammonium chloride. Okay, so this process is used in actually purification of this petroleum, crude petroleum. So they will have huge fractionation. They'll have huge, what you call like a test tube, big fat test tube. So you have a separation of different. These are all what are called as volatile, because it is getting converted into water vapor, into vapor state. So they get deposited, and you will have different fractions. They call as regions, where you are having one substance, higher one wherever you are having lesser melting point, you are having one region. So different fractions. Okay, so good doubt, Prerna. So is it clear now? I think sublimation is much clearer with the doubt, students.
Yes, ma'am.
Very
Yes,
good.
ma'am.
Okay, good. Okay, next, what is the next question? Who will take up? So Sneha finished.
Ma'am, can
Who
can I?
wants to? I think we'll give Spurti a chance. No, Spurti has not got a
Why?
chance.
Why does our palm feel cold when we put some acetone or petrol or perfume on it?
Very good. Good question. Yeah, okay. Why does your hand feel cold when you're putting a drop of perfume?
When we
Hmm.
when we put perfume or acetone on our palm, it comes in contact of air, and it uses our the palm's energy to convert into water vapor,
Uh,
and thus it evaporates by causing cool.
Very good. So actually, when I'm putting it on the palm, whether it is acetone or if it is perfume, so the acetone molecules or perfume molecules taking the energy from my hand palm, and it is getting converted to the vapor state or to the gaseous state, and that gas molecules will move. They will diffuse into the air, and they will like, because of the higher kinetic energy, they move fast, and I am able to get the smell of the perfume or the acetone molecule. So you are having so many principles. You are having evaporation, then you are having diffusion, you are having the effect of kinetic energy, all this taking place. But what we see is perfume smell we are getting, isn't it? So many principles of chemistry. Very good, Sneha. Spurti. Next person, who is it? Let me see. Sahana. Next question.
Yes, ma'am. Are we able to sip hot tea or milk faster from a saucer rather than in a cup?
What is the answer?
Tea in saucer has larger surface area than in cup. The rate of evaporation is faster with increased surface area. The cooling of the tea in saucer takes place sooner than in a cup.
Very good. Excellent. So because of the cooling is faster because of the larger surface area. So we can see that we can drink tea without burning our lips. Very good. Excellent. Good. Okay. So next, who is it after Sahana? Is there anyone? Sahana is the last.
Yes, ma'am.
Okay. We'll go back to Aishwarya. Next question, Aishwarya.
Yes, ma'am. What type of cloth should we wear in summer?
Okay. So very good. We discussed that. So what is the answer?
We should wear cotton cloths in summer season
Why?
because the cotton is a good absorber of heat, ma'am. And in summer season, we sweat a lot, and cotton cloths um, absorb sweat from our body, and it causes cooling. It causes cool to our body.
Yeah, so this it is a good absorber of moist water and sweat. It absorbs sweat, and then sweat evaporates very fast. So we feel cooling. So more and more sweat gets evaporated, our body feels cold. So here now I'm having an example. See, I kept that. See, that time I showed you when I added water. And I kept, you could only see it had become sort of cloudy. Now can you see water slowly dripping?
Yes, ma'am.
Students, so
Yes,
slowly it
ma'am.
is dripping, it is falling. Yeah. So more and more water molecules, from the water vapor from the air, they're coming in contact because air is moving. There is movement. So more and more water vapor is coming in contact with this cold surface, and it is getting converted to the liquid phase. So till how long will it take place? Till how long this process will go on taking place, students? Any answer?
When the ice become totally cold, the water, it will not.
When
Very
the
good.
ice melts,
Yeah, very good. But when the ice melts completely, see, even though ice melts, no, it actually, when it is melting, we studied that there is some heat inside. So it is taking heat. For the ice to melt, it is taking heat. So that heat is also coming from the atmosphere. So that also actually, so many processes taking place. So the heat from the atmosphere is taken for melting of ice. Okay, the surface is cold. As a result, the surface is cold. So as a result, the water vapor that is present in the water will get converted to liquid because of the humidity. Again, the humidity at this temperature of water, the humidity is low. So excess water vapor will get converted to liquid. So we can see so many principles that we have studied being applied in this particular a simple phenomenon that we see in our daily life. Okay. So next question. Akash, you read the next. Is there a next question?
No, ma'am.
No, ma'am. Questions are finished.
No, ma'am.
Okay. So after
They
that,
are
what do we have? Because I don't have the textbook with me. Okay. So after that, what do we have, Akash? Next.
More to know.
More to
And
know.
about the 5 states of matter.
Okay.
Now scientists are talking of 5 states of matter: solid, liquid, gas,
Very good. Continue.
Bose, Einstein, condensate, plasma. The state of consist of super electronic, enteric, and super excited particles. These particles are in the form of inside gases. The fluorescent tube and neon zinc bulbs consist of plasma. Inside a neon zinc bulb, there is a neon gas, and inside the fluorescent tube, there are helium gas or some other gas. The gas gets inside in an ion side that is gets charged when electric energy flows through it. This charges up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature.
Very good. So here we are saying, actually, see, we have been saying 3 states of matter, but that they are saying that with more and more research and advances, actually there are 5 states of matter. So now we discuss the 4th state of matter. So 4th state of matter, see, whatever we studied so far, that has been applicable. See, we studied the effect of temperature, we studied the effect of pressure. That is with respect to the 3 states of matter. Now in the 4th state, it has different properties. So in this, first we'll take a plasma. Plasma, the molecules are ionized. So the gases are in the what you call as present as ions. Okay. Now, anyone tell me what is this ions?
Charged species.
Charged species. Charged pieces. Very good. Why are they charged species? Why are they having a charge? Okay. Let us say, for example, let us take up. See, if you take up oxygen, so oxygen is always present as O2. You're having 2 atoms of oxygen present together. Like you always write it as O2, no? You never write it as O, isn't it?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So actually, when you are actually taking only O, it will have a charge. If you're taking the atom as such, it will have a charge. So actually, this oxygen, if you take as such, it is having a negative charge. So it is actually having we can, in simple words, 2 negative charges. So it can combine with hydrogen, which is having 1 positive charge. So 2 hydrogen will have 2 positive charges. So these 2 together will get neutralized, and we are having water molecule. I mean, in simple words. So, but if it is only oxygen as such, it will have different properties. If it is only O, it is in the ionic state. It is in the charged state. It is trying to come to the stable state. So it will try to attract 2 protons because it is having 2 negative charge. Sorry, it is trying to attract. Actually, it needs 2 electrons. You have studied different shells, outermost shell, 2 electrons, a structure of an atom. Huh?
No, ma'am. Yes, ma'am.
Ma'am.
Okay, we'll okay, we will see what the textbook says. In plasma, they are present in the charged species. Okay, so when you're passing current, the gas gets converted to a charged, it gets ionized and it is present as this charged species. So charged species will have certain property. Okay, so depending on that gas, it will have, like it will start glowing, and we will see, depending on the gas, neon gas, you see that color. And what we see finally, if you're seeing the, let us say, take up a fluorescent bulb, it is having a particular color. That is because when you're passed electricity, the the gas inside has got charged because it's electric current, and it is exhibiting some property which I am seeing as white light. Okay, so when I'm charging it, it is getting converted to what is called as, when I'm passing electricity, it is getting converted to
Ions.
Ions. Okay, so this state, we call it, it is called as the plasma. Okay, now what we will do is whatever Akash read, that particular, we'll just complete that. Farhan, can you read that particular aspect about plasma, so that, we will just go
Yes,
back
ma'am.
again.
The state consists of super energetic and super excited particles. These particles are in the form of ionized gases. The fluorescent tube and neon sign bulbs consist of is helium gas or some other gas. The gas get ionized. That is gets charged when electrical energy flows through it. The charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of gas. The sun and the stars glow because of their presence of plasma in them. The plasma is created in stars because of very high temperature.
Very good. Okay, so what did you understand, Farhan, now?
The plasma is ionized, ma'am. It is having very high temperature that is found in stars and sun. It is helps to glow sun and stars.
Okay, very good. In our daily life, where do we see this plasma? Anyone?
Ma'am, bulb.
Yes,
Bulbs.
Bulbs. So we have two types of bulbs. One is this fluorescent bulb, what we call like tube light, no? Okay. And then you are having neon bulbs, which will be having glowing red color and color bulbs you are having. Okay, both are different types of gases present. So whatever the gas that is present, fluorescent means it is giving light. Okay, fluorescent bulb. Neon is giving different colors, like. Okay, so in fluorescent, what is happening? This gas, when you're passing electricity, this gas, it can be helium, it can be neon, whatever may be the gas, that gas gets charged, it gets ionized. So these ions will exhibit, they get converted to the plasma state, and they exhibit, depending on the gas, different colors, or they have a fluorescence. Okay, so this is what we see in our daily life. Plasma, we have actually a lot of research work has been done. That is how this neon bulbs, all this have been as a result of lot of research work. But in nature, we see plasma inside actually in the sun and in the stars. So because of high temperature, the gases inside, they're in a state of, they're ionized and they emit light, and depending on the elements that are present, heat also, and as a result, we see, we say sunlight. Okay, so this is the fourth state of matter. Is it clear, students? Plasma, at least you got an idea what is plasma?
Yes, ma'am.
Very good.
Yes, ma'am.
Very good. Okay, so today we will, so it is time. So all students, thank you. All of you have a great day today.